Continuing from last video, looking at our next function, our graph looks something like this, which we know to be our square root function, so that's going to be f of x is equal to the square root of x. Our next graph looks like this, and we know that graph to be our cubed root function, so that's going to be f of x is equal to the cubed root of x. And our last function, our graph looks like this, and that's going to be the absolute value of x, so it looks like f of x is equal to the absolute value of x. Okay, so for this first one, we're going to look at these transformations, and we know that our first transformation is going to be a shift left by 3, and our second transformation is going to be a reflection over the x-axis. So what it's going to look like is we first want to shift our original graph to the left by 3. So 1, 2, 3. So then it's going to look something like this for our first transformation. And we want to reflect this one down. So then it looks something like this for our second transformation. So then our final graph should look like that bottom graph. Number 33 says given the function y equals f of x, use the transformations to graph y equals -2 f of x plus 1. List the transformations in the order to be applied. So we're actually going to do this one on the next page where the graph is. So our transformations in order is going to be first, we're going to shift left by 1. Our second transformation is going to be to stretch vertically by a factor of 2. Then our last transformation is going to be reflecting about that x-axis. So our first transformation is we're going to shift this graph to the left by 1. So we're just going to move all those points to the left by 1. Then our next transformation is going to be stretching it vertically by a factor of 2. So we're going to stretch this graph up by 2. So then it's going to look like this. And then our last transformation is going to be flipping that blue graph over our x-axis. So it's going to look like this. So our final graph is going to look like this green graph. So our transformations for this graph are going to be, our first one is going to be a horizontal shrink of 1/2, and that comes from this 2 right here. And then our next one is going to be shifting down 3 units, and that comes from that -3. And so when we look at our original function, it goes from, right? And then our first change is going to be that horizontal shrink by a factor of 1/2. So we're going to basically push the sides of this thing in by 2. So it looks like this. And then we want to reflect it over the, or we're going to shift down, not reflect, sorry. We're going to shift down by 3. So we're just going to move this top portion down by 3. And then we'll end up like this. And then this green graph is going to be our final graph. Okay, for this next one, we're asked to graph the transformations of this function. So we're going to head over to the next page where the graph is. Here it is. And let's list out these transformations first. So our first transformation is going to be our shift 2 units to the right. 2 units right. And that's from that -2 inside of that function. And then our second one is going to be to stretch this vertically by a factor of 2. and that's from that 2 on the outside of that function. Then we're going to reflect this about the x-axis. Reflect x-axis. That's from that negative sign out front. And then our last transformation is going to be moving this up by 1. So shift up by 1. And that's from that +1 on the outside. So step 1 of this transformation is shifting this 2 units to the right. So we're going to be roughly about here for our first transformation. And then our next transformation is going to be stretching this, or stretching this vertically by a factor of 2. So what we're going to do is we're going to basically multiply all these points by 2. So this is going to move up to here. This point's going to move up to here. It's going to be here, and then that last point is going to be all the way down here at -4. So then our line would look like this. Really more like this, right? And then that next transformation is going to be reflecting it over the x-axis. So those points, we're just going to flip this blue line over the x-axis. So we just kind of map all these points. So then it looks like this, right? And then our last transformation is going to be shifting this up by 1. So we're just moving all of these points up by 1. So then our graph looks something like this. So that yellow graph is going to be our final transformation. This next question is asking us to write this function with the transformations based on our parent function y equals the square root of x. So just going down the line, step 1 is to shift 3 units to the left, which means we're going to do that inside of our function. So we're going to say y equals the square root of x plus 3. And then our next transformation is stretching it vertically by a factor of 4. So we're going to throw that 4 out in front, and we're going to say y equals 4 times the square root of x plus 3. Our next transformation is reflecting across the x-axis, which gives us a negative sign out front. So then we get y equals -4 square root of x plus 3. And then our last transformation is shifting it up by 5 units. So we just need to tack a plus 5 on the end of our function. And so we get -4 square root of x plus 3 plus 5. So this is our final function here. Doing the same thing for this one, except we have y equals the absolute value of x. Our first transformation is to shrink it vertically by a factor of 1/5. So we're going to throw a 1/5 out in front, and we're going to say 1/5 times the absolute value of x. The next one is to stretch it horizontally by a factor of 2. And remember, when we're doing things with our x-axis, it's opposite of what we may think. So we have y equals 1/5. We're going to throw a 1/2 instead of a 2 on the inside. Then our next transformation is going to be reflect about the y-axis. So remember, our x-axis is on the outside, our y-axis is on the inside. So then we have a -1/2 x. And then our last transformation is to shift it down by 4. So we're going to subtract 4 on the outside. And so our final function will be y equals 1/5, the absolute value of -1/2 x minus 4. So we are trying to determine if these functions are symmetric about the x-axis, y-axis, origin, or none. So to test that, if a function is symmetric across the x-axis, that means if we plug in -y into the equation, then the equation is equal to when a positive y is in there. So let's test that out. So we have y equals 3x squared plus 2. If we have -y equals 3x squared plus 2, those are not equivalent, so it is not symmetric about the x-axis. To test if it's symmetric across the y-axis, we do the opposite. So we plug in a negative x in for x and see if it's equivalent. So we have y is equal to 3 times negative x squared plus 2. And a negative x squared is equivalent to an x squared. So we get y equals 3x squared plus 2, which is what we originally had. So this function is symmetric across the y-axis. To see if it is symmetric across the origin, we do both. So we plug in a negative x and a negative y, and we see if it looks similar. So we say negative y equals 3x squared plus 2. We know that a negative x squared is the same as an x squared, but we still get negative y, 3x squared plus 2, and that is not equivalent to our original function, so it is not symmetric across the origin. So not symmetric. Across the origin. So we're going to implement that same process when we say 2x minus y squared equals 3. And if we plug in a negative y, we get 2x minus negative y squared equals 3. And a negative y squared is the same as a y squared, so we get 2x minus y squared equals 3. And so we know that it's symmetric across the x-axis, right? If we were to plug in a negative x, we would get 2 times negative x minus y squared equals 3. Then we get negative 2x minus y squared equals 3. And that is not equivalent to our original function, so it is not symmetric across the y-axis. So again, to see if it's symmetric across the origin, we're going to plug in a negative x and a negative y. So maybe we get 2 minus x minus negative y squared equals 3. And then we get negative 2x minus, that turns into a positive y squared equals 3. But this is still not original as our original function. So it is not symmetric across the origin. So we're going to be going through the same process with this one. We have x squared plus 3xy equals 2. And we're saying if it's symmetric across the x-axis, so we plug in a negative y. So we have x squared plus 3x times negative y equals 2. We can change that to x squared minus 3xy equals 2, and that is not the same as our original function, so it's not symmetric across the x-axis. Next, we want to see if it's symmetric across the y-axis, so we plug in a negative x, so then we get negative x squared plus 3 times negative x times y equals 2. This is going to be an x squared. We're going to have a minus 3xy equals 2. That is not the same as our original function, so it's not symmetric across the x or the y-axis either. Checking if it's symmetric across the origin, we plug in a negative x and a negative y. So then we're going to have negative x squared plus 3 times negative x times negative y equals 2. This negative x is going to turn into a positive x squared, and these negatives are going to cancel out here, so we're still going to have that plus 3x times y equals 2. So now this function is the same as our original function, so it is symmetric across the origin.